Okay, question 7. Find the equation of the normal to the curve x cubed plus 2x squared y equals y cubed plus 15 at the point 2, 1, giving your answer in the form ax plus by plus c equals 0, a, b and c are integers. Isn't it nice to see that? That kind of brings back happy memories of core 1, because that was always how they asked us to do tangents and normals in core 1. Okay, if we're under any doubt about this, as soon as we read find the equation of tangent and normal, right from core 1 days, that should have triggered in our mind that we need to do dy by dx. So we need to differentiate this with respect to x. A really important thing, in the mark schemes they'll allow you to get away with this as long as it doesn't turn into a wrong answer. But you really, really shouldn't be writing dy by dx equals when you start doing this. Okay, because that's not what you're doing. You're not equating something to dy by dx. You're differentiating each term. So don't, if that's a habit you're in, to get out of that habit, don't write dy by dx at the start of this. We are differentiating each term with respect to x. So we go through them one at a time. If you need something to remind you of what you're doing, then you could write the full kind of formal thing of saying we are differentiating each term with respect to x. It's a bit over the top, but you could write that just to be really clear about what you're doing. And then that gives us 3x squared. That bit's easy enough. Now, what we've got here is a product. We've got 2x squared times y. So we have to use the product rule to differentiate a product. And the product rule says it's the first thing times the derivative of the second, and differentiating y with respect to x gives us dy by dx, plus the second thing multiplied by the derivative of the first. And if we differentiate 2x squared, we get 4x. So that's that bit dealt with using the product rule, and they'll give quite a few marks just for doing that. The next bit is similar to the example I gave a few moments ago. We're going to differentiate y cubed with respect to x. We can't. We have to differentiate y cubed with respect to y, and then multiply by dy by dx. So that bit gives us 3y squared dy by dx. And that gives us 0, doesn't it? If we differentiate 15 with respect to x, we get 0. So this is what we've got. We need to know the gradient at point 2, 1. So that's what we're going to work through now. We need to get dy by dx on its own. Let's throw a few things over to the other side. What can we do? We've got 3x squared plus 4xy equals 3y squared dy by dx minus 2x squared dy by dx. So 3x squared plus 4xy is, and I've rather laboured this, but you get the idea. Simplifying that side to get dy by dx on its own, and then divide by this to give us 3x squared plus 4xy over 3y squared minus 2x squared. Now, I didn't have to, but I have taken this to a point where I can see what dy by dx is. I didn't have to do this. What I could have done, I wouldn't have enjoyed it so much, but at this stage here, having differentiated it, I could have subbed in the points x equals 2 and y equals 1 straight away, and then simplified it to get what dy by dx was from that point. I didn't have to get to dy by dx equals. It's a bit neater to do it that way, but there's nothing wrong with doing it there. So we had the point 2, 1, which gives us dy by dx as being 3 times 2 squared plus 4 times 2 times 1 over 3 times 1 squared minus 2 times 2 squared, which gives us some numbery kind of stuff. 20. Yeah, that's going to be minus 5, isn't it? So we've got negative 4 as our value of dy by dx. The question said find the normal So the normal gradient, lovely bit of core 1 coming back into this here, is the negative reciprocal of that. So plus a quarter. And so we've got y minus y1 is m x minus x1. So 4y minus 4 is x minus 2. Giving us, all right, we wanted it all on one side, didn't we? Yeah. So giving us 0 equals x minus 4y plus 2 as our final answer. Was that what it got? Yes. There we are. I thought of something to say. Oh yeah, have you noticed? I've got a calculator on the desk, but we've done, what have we done now? Is that 4 questions that we've done from this paper, and I haven't picked up the calculator. You could almost make core 4 a non-calculator paper like core 1, couldn't you? Just thought it was interesting. Right, that's maths.